Imagine waking up one day to find that all the continents have merged into one. What would that world look like? A planet where distant places are now neighbors, where oceans are reshaped, and once isolated species are now in direct contact. Envision a world where the familiar geography of today is replaced with an alien landscape. A single, massive continent. Seems like a far-fetched idea, doesn't it? But what if I told you that it has happened before? Welcome to the world of Pangea, a supercontinent that existed about 335 million years ago. Imagine, if you will, a time when the world was one massive landmass surrounded by an immense ocean. This, my friends, was Pangea. The word Pangea itself comes from the ancient Greek, meaning all lands. It paints a vivid picture of a time when all the continents we know today were fused together in a singular massive supercontinent. Now, how did this mammoth landmass come to be? Well, it's all down to the magic of plate tectonics, the theory that explains how the Earth's outer shell, the lithosphere, is divided into several large slabs called plates. These plates, floating on the semi-fluid layer of the mantle beneath, move, collide and diverge, driven by the heat deep within the Earth's core. Over hundreds of millions of years, their slow and relentless movement brought all land masses together, forming Pangea. But the world as we know it today is quite different, isn't it? So, what happened? Again, the answer lies in the ceaseless dance of plate tectonics. Roughly 175 million years ago, Pangea began to break apart. The same forces that had once pushed the continents together began to pull them apart. The supercontinent cracked, fragmented, and the pieces drifted away from each other. Over millions of years, these fragments evolved into the familiar continents of today, scattered across the globe. It's quite a journey, isn't it? From a unified supercontinent to a world of diverse, separate landmasses. But the story of Pangea and the continents isn't just a tale of geological history, it's a testament to the dynamic, ever-changing nature of our planet. It's a reminder of the unimaginable forces that shape and reshape the Earth, crafting the world we inhabit today. So, Pangea isn't just a figment of our imagination, but a real chapter in Earth's history. Our continents aren't static, they shift, they move, they drift. This is the science of continental drift. Imagine Earth as a giant puzzle with each piece representing a continent. Now these pieces, or tectonic plates as we call them scientifically, are not fixed. They are adrift on a semi-fluid layer of molten rock known as the asthenosphere. It's like a slow-moving conveyor belt, where these massive landmasses casually float on top. The theory of plate tectonics, put forward in the mid-20th century, gives us a comprehensive explanation of how these continents move and shape our planet. This theory suggests that the Earth's lithosphere, its rigid outermost shell, is broken into several large and small pieces called tectonic plates. These plates are like the skin of an orange, fitting together but always moving, driven by the heat from Earth's core. Now you might be wondering, how does this heat cause the movement of tectonic plates? Well, the answer lies in the process called convection. In the Earth's mantle, the layer between the crust and the core, heat from the core causes the rocks to rise, while cooler rocks sink. This cycle of heating, rising, cooling and sinking creates convection currents that act like a giant slow-moving engine, driving the movement of the tectonic plates. These movements, although slow, have monumental implications. They are responsible for the creation of mountain ranges, earthquakes, volcanic activity, and the drift of continents. Over millions of years, these movements have led to the formation and breakup of supercontinents, the most famous of which is Pangea. Pangea, a term derived from the ancient Greek words for all lands, was a supercontinent that existed around 300 million years ago. It was a result of the slow but persistent movement of Earth's tectonic plates. However, the same forces that brought these continents together also tore them apart, leading to the geographical configuration that we see today. This constant movement of Earth's crust is what led to the formation of Pangea and its eventual breakup. So the next time you look at a world map, remember that it's not just a static image. It's a snapshot of our Earth in motion. Now here's the kicker. What if the world is shifting back to Pangea? Imagine, if you will, the continents as enormous puzzle pieces floating on the surface of our planet. These pieces are not static, they're moving, albeit very slowly. Now what if I told you that these pieces, these continents, are slowly inching their way back to each other like long-lost friends reunited? This isn't a hypothesis plucked out of thin air. It's grounded in the solid bedrock of geology and plate tectonics. You see, the Earth's crust isn't a single unbroken shell, rather it's a mosaic of tectonic plates. These plates float on the semi-fluid layer of the mantle beneath, and as they move, they carry the continents along with them. In the past, we've seen this movement lead to the breakup of supercontinents and the formation of the world map as we know it today. But what if the trend is reversing? What if the continents are converging once again? Geologists and paleontologists have been piecing together this puzzle for years. They've studied fossils, mountain ranges, and the seafloor to understand the past and predict the future. And the evidence points to a fascinating possibility: the formation of a new supercontinent. We've even given it a name, Pangea Proxima, or Next Pangea. This future supercontinent is predicted to form over the North Pole in about 250 million years. The Atlantic and Indian Oceans would close, while the Pacific Ocean would become a vast encircling sea. But don't start packing your bags just yet. This process is happening at a snail's pace. We're talking about a few centimeters per year, about the same speed at which your fingernails grow. So while the continents may be on a slow dance towards each other, we're unlikely to see this reunion in our lifetime, or even in the lifetime of our species. But isn't it fascinating to think that the face of our planet is continuously changing, sculpted by the relentless forces of nature? This isn't a quick process, but the evidence suggests we're on a slow journey back to a single continent. So, what does this mean for us, for our future generations? As we grapple with the concept of our world shifting back to a single supercontinent, Pangea, we must consider the profound implications this could have on our planet and our lives. The potential changes are vast, affecting everything from climate to biodiversity, and even the very fabric of human civilization. Imagine for a moment one massive continent stretching from pole to pole. This would result in a drastic alteration of our planet's climate. The interior regions of this supercontinent could become incredibly dry and hot, with coastal areas experiencing more moderate conditions. This could lead to extreme weather patterns and a shift in the distribution of our precious water resources. This new climate could also have a significant impact on biodiversity. Species, both plant and animal, would have to adapt to new habitats or risk extinction. As the continents merge, ecosystems would collide, creating new challenges for survival. Species that once thrived might find themselves on the brink, while others could seize the opportunity to flourish in new habitats. And then there's us, the human race. How would a return to Pangea affect our civilizations? Our societies have been shaped by geographic boundaries: oceans, mountains, deserts. These natural barriers have defined our cultures, our politics, and our economies. But what happens when these barriers are no more? We could see a blending of cultures like never before, or we could see conflict as people grapple with a world that's dramatically different from the one they know. Could we adapt to this new world? Could our technology and ingenuity help us navigate these changes? Or would we face a future of uncertainty and upheaval? These are questions we can't answer with certainty, but they're important to consider as we look to the future. The return to Pangea could reshape our world in ways we can barely imagine. This is not just a scientific curiosity, but a profound shift that could redefine life as we know it. As we continue to uncover the mysteries of our planet, we're reminded of our place in the natural world and our responsibility to protect it. So there you have it. The world as we know it might be shifting back to a single continent. We started by introducing the concept of Pangea, the supercontinent that once held all of Earth's landmasses together. This was a world vastly different from the one we know today, a single gigantic landmass surrounded by a vast ocean. We then dove into the science behind continental drift, the slow and steady movement of the Earth's crust over its molten interior. This is a phenomenon that has been happening for billions of years, shaping and reshaping the face of our planet. It's the force that broke Pangea apart and spread its pieces across the globe, creating the continents we know today. But now, evidence suggests that we might be heading back to where we started. The continents, drifting on their tectonic plates, are moving towards each other at an exponential rate. If this trend continues, we might see the return of Pangea in the far, far future. And what does this mean for us, for our planet? There are many implications to consider, from drastic changes in climate and biodiversity to potential geopolitical shifts. It's a subject that invites endless speculation and discussion. It's fascinating. It's a bit scary, but above all, it's a testament to the ever-changing nature of our planet.